and we'll hopefully get to them later on. And the participants are all muted at this point, except for our presenters here. And we're going to be unmuting all presenters at the end. And this presentation is currently being recorded and will actually be emailed out to all the participants after this presentation, along with a 90-day free trial for RETScreen Expert. So in terms of our presenters today, my name is Dan Ritchie. I am the Green Hospital Scorecard Manager with the Canadian Coalition for Green Healthcare. And I'm joined here along with JJ Knott, Healthcare Energy Leaders Canada, and Stephen Dixon from No Energy, and Kevin Burke from Natural Resources Canada. And so to sort of go in before we talk about our main event, RETScreen, we're going to talk a bit about the Green Hospital Scorecard and how it relates to energy and also RETScreen. So the latest iteration of the Green Hospital Scorecard was the 2018 Green Hospital Scorecard. And this involved creating a generated scorecards for over 101 participants. So as you can see in this chart here, this program's been going on for 6 years and it's currently in its 7th year. And so last year in the 2018 Green Hospital Scorecard, 101 scorecards were generated through participants answering data through a survey on energy, water, waste, pollution prevention, and other topics. And so there are particular questions that we've had throughout our energy survey. And here's a bit of a quick introduction of what you would see on the beginning of the survey. And it's talking about particular fuel types and energy sources that hospitals were actually using. And to sort of go a bit more into detail of the survey, we did ask specific questions around NRCan's programs and tools. We asked whether their hospitals have a purchasing policy that relates towards Energy Star and particular products. And then there was also a survey question that asked hospitals whether they actually utilize particular tools and programs that are offered by Natural Resources Canada. So tools such as Portfolio Manager, the RETScreen Expert Energy Management Software, which we'll be going over to today, and then also a simple savings calculator. So in 2018, we got 101 responses to these specific questions. And here is a bit of the results that we did find from those from that particular Green Hospital Scorecard iteration. So from 101 respondents, we did notice that 12 sites are engaged with RETScreen Expert Energy Management Software, as well as 18 hospitals responding that they're involved with the Simple Savings Calculator and the Energy Star Portfolio Manager. We had 33 sites stating that they are involved with this, integrating this tool. So to sort of talk about particular energy policies and planning that was in place, hospitals did allot a particular budget that went towards energy in sort of staff engagement, outreach, and programming. So that was about 50. So around half of respondents stated that they do have staff engagement around energy, and having an explicit energy policy or energy conservation policy. We had 71 respondents out of the 101 from the 2018 Green Hospital Scorecard. And then hospitals also stated that they have energy conservation action plans with 66, and then also energy conservation targets was stated at 67 particular sites. So within our energy survey questions, we also offered questions that were trying to gain insight in towards renewable energy sources that hospitals have actually been involved in. So asking about their particular projects, and here are just a list of examples. So listing from whether hospitals have actually implemented biofuels, biogas, energy, biomass, and ranging from a whole list of other renewable energy sources. And then we also asked hospitals which sources of renewable energy they're actually considering here in the future. So to show those results from the 2018 Green Hospital Scorecard, we did see that there was a high level of sites, so 60 sites that have actually not integrated a renewable energy source at this point, and then 15 stated not applicable. The highest level that was actually integrated was solar voltaic with 9 responses. And then in terms of the renewable energy sources that are considered for the future, solar photovoltaic was leading in terms of 45 sites stating that they were considering these types of projects in the future. And then that was led behind by micro hydro systems with 14, and then geothermal projects with 13. So in terms of the Green Hospital Scorecard, right now we are actually in the most recent call for data. So we're asking for data from hospitals across Canada. And in asking for this data, the coalition has a high level of confidentiality. So we are respecting all responses from hospitals, and that information will be stored in a secure platform that won't be shared with any other particular sites unless it's de-identified as the one that's shown before. So in terms of participating and in getting your hospital involved, we're currently asking for data call from hospitals from across Canada. And if you're interested in becoming involved, we have a website here, so the Green Hospital Scorecard FAQs site, which you can follow to gain more insight and information. And here's a list of the survey link if your hospital site or one of hospitals within your network are interested in completing. And if you have any further questions about the Green Hospital Scorecard and how your site can actually become involved, you could email me at dan@greenhealthcare.ca. And our deadline for submission is March 30th, but there is a definite potential of extending that for particular sites. So I want to say thanks, and we're going to sort of jump into our next presenter, JJ Knott, to sort of dive into RETScreen Expert. So JJ, whenever you're ready. Yeah, cheers. And so I'm just passing over the presenter role to JJ.
Yeah. All right, Dan, I've got the screen magnified here for some reasons.
Oh, sorry about that. Yeah. I'll just share my screen and then pass over the mouse controls for you.
Okay.
Yeah.
And we have it now.
Yep, if you're using your arrow keys, yeah, you have the mouse controls.
Okay.
Yeah.
All right. Just need so today I'm going to just talk about how RETScreen is being utilized by different organizations across the country. And is everybody seeing the screen okay? I've got a participant.
Looks great.
I have a participant list on my screen here, Dan.
You can X that out.
Yeah.
All right, so everybody sees the screen clear then?
Yep.
Okay, great. So the first RETScreen example of how organizations are utilizing the tool comes to us from the folks at Efficiency Nova Scotia. They're currently using RETScreen to evaluate the energy and cost-saving potential of proposed projects. A lot of times as facility managers, we rely on consultants to put together very detailed cost and savings estimates in relation to projects. And now we can use this tool to quickly reconcile these estimates by inputting project details into the RETScreen program and with the touch of a button running an analysis on the project. RETScreen will not only give us those direct savings estimates, but as in the case with lighting projects, it will also give you passive saving information as well, such as heating and cooling load impacts or carbon reduction figures, which are really handy to have. You can do it through the archetype system. So if you're in a hospital facility, for example, you can use the hospital archetype to run analysis through that, or you can go into the library of equipment information that you can find in RETScreen, which is really handy. So if you have a specific boiler, for example, that you want to look at compared to another boiler system, you can do that comparison through the specific equipment listing. If you have your building detailed into the RETScreen system, you can achieve very precise levels of analysis. And as I say, it's a very handy tool to use. It all comes together very quickly once you get into the system and get working with it. And it also includes the ability to analyze projects involving renewables. Dan mentioned a little bit about the renewable projects that people are interested in the Green Hospital Scorecard questions that we asked. And you'll see a little of that further into the presentation today. Dan, maybe you should take control of this. I got my arrow keys just don't seem to be working, so.
Yeah, sure. All right, so I can go to the next thing.
Yeah. So in our previous RETScreen webinar, we noted to folks how RETScreen can be used to pinpoint your facility location anywhere in the world. And RETScreen can also be used to detail weather data pertaining to that location. There's a whole bunch of NASA weather data loaded into the RETScreen system, and that automatically gets downloaded into your pinpointed location. And so you can weather correct your building for benchmarking and other purposes. I just threw in some of these reminder slides so that people will see once again what kind of detail you can get out of RETScreen. Next slide, Dan. So there's also a myriad of ways that through RETScreen you can run financial analysis of a project, from energy to cost to emissions, and a lot of different sensitivity analysis that you can do through the RETScreen tool. It's all there at your fingertips. Next slide. So building that envelope application, in this particular utilization of RETScreen, we had an organization that put out an RFP for a roof replacement. And the specs were open to a number of different types of roof application options, and 4 proposals were received. In order to aid in the valuation for each option, so that the organization knew that they were getting the best bang for the buck, the different systems and R values, we loaded them into RETScreen, and a financial analysis was completed for each. And the resulting numbers certainly help the organization make a very educated choice on what roof application they should consider above others. So I thought I'd throw that in there because a lot of us run into these building envelope applications, and RETScreen is certainly a good tool for analysis of different building envelope options. Next screen, Dan. And as per our last webinar, we also stressed the standardized process and validated methodologies used within the RETScreen program. And this is good because this really helps the facility folks zero in on what projects have more potential for success than others. And we all know that those successful projects lead to funds for further projects. And it's great to have this tool to help us prioritize projects especially when it comes to budget time. You know, and I know that when it comes to budget time, we all have this great list of projects in front of us, but with limited funds, we can't do them all. So it's good to have something to help us look at what projects might be more successful and prioritize those specific projects. Next slide, Dan. So this project comes to us from Peterborough Regional Health Center, and it's an interesting project in which the folks at Peterborough utilized RETScreen to reconcile numbers that were derived through a consultant and which applied to a lighting replacement and control project. And the consultant's report, of course, was many, many pages long. And so you go through it with a fine-tooth comb with all the detail, or you can load it into RETScreen, and the system replacement proposal basically involved installations of some fairly sophisticated controls, as well as lighting system replacement. And the controls would involve occupancy, vacancy, sensing of areas of the facility. And the control of the lighting systems and the energy saving potential of the light fixtures both came into play in terms of savings as far as energy goes in this project. Both the light systems before and after, as well as lighting system schedules, were used to analyze the project potential through RETScreen. And in this case, the sensitivity of the light on-off schedule was given a lot of consideration. So bottom line is, using a very conservative base case, it was ascertained that the project would have a 3.1-year payback. And incidentally, as it turned out, this projection was very close to what the consultant had calculated. So it was great to reconcile their numbers through RETScreen. Next slide, Dan. So as the Peterborough folks got further into the project, they started to entertain a proposal that would see the HVAC system controls tied into the equation, and the HVAC system cutbacks and temperature setbacks could also occur in relation to occupancy, vacancy of space within the facility. So this would mean to them, of course, an increase in project cost to the tune of triple of what the original lighting system project cost was going to be. But again, RETScreen analysis was completed on this portion of the project, and the total project now showed a payback of 3.6 years. So not much of a difference from the original, which just included the lighting and controls. Now you're putting the HVAC system into the equation and realizing a 3.6-year payback. Not to mention the huge reduction in carbon emissions, which we were able to show through RETScreen. And credit to the Peterborough Regional Health Center folks. This played a big part in the organization's decision to move the project forward. Next slide. So again, in our last webinar, we talked about RETScreen and persuasion. And RETScreen is a great system when it comes to the ability to graph financial information over time, track project performance over time, and we'll see a great example of that in the next project example. And to speak in terms that the finance folks understand, RETScreen not only calculates payback, return on investment, net present value, cost-benefit calculations, it also cranks those numbers out in a nice-looking report at the touch of a button. And to me, you know, from the facility side of things, this is a great thing to have at my disposal. Is, you know, hit a button and out comes a 12-page report that's very polished, and it happens within seconds. Next slide. So this example, to me, is a brilliant example of the use of RETScreen for energy tracking purposes. This comes to us by way of the folks at Service New Brunswick. The building in question is approximately 10 years old and was built to energy efficient standards. However, it's benchmarking 10 kilowatt hours per square foot higher than the average, and this was a cause for concern for the folks that service New Brunswick. When they drilled a little deeper down into the issues, they found equipment and control issues and manual overrides in place to overcome these issues. And I think we've all seen this, even in new buildings where, you know, equipment, the controls just don't seem to be doing what they're supposed to do. And so we start to see some manual overrides of the system in order to get the equipment to function close to what we'd like to see it function at, but not quite the way it was meant to. As a result, the commissioning contract was let and work is currently underway. Next slide. And so the Service New Brunswick, the folks there are tracking the energy use, being done from a baseline year, 2017-18. And from this information, weather-corrected energy use is predicted now on a monthly basis and then compared to actual. And the recommissioning agent is tasked with training the staff on standard operating practice as the equipment and controls are being fine-tuned. The staff have learned, of course, to respond to the moment if there is concerns raised about environment within the facility, but to track and report overrides and adjustment to control settings. And the commissioning efforts are all being confirmed by a third party, so everything's they've got all kinds of checks and balances in place. And the RETScreen tracking is used to confirm savings as the project moves along. And I'll show you examples of that. Next slide. So here you can see the tracking of the energy use for the facility. And you can see that the bars are the predicted energy use and the line the actual. So in some months, energy use is gained, in others, it is slipped. So this information is taken back and used to illustrate the concerns with staff and contractor alike. So if there's some slippage in energy use, then they can go back and see what happened in that month, or, you know, what have we done, what kind of settings are in place to make that happen. If there's gains, that's good, that's what they're shooting for. And next slide. And so from one year to the next, this continues. And so as the project moves along, the tracking continues. And of course, again, the results can be shown to staff, they can be shown to the commissioning contractor, so that everybody has an idea of what they're achieving as the project moves along. Next slide. So RETScreen also has a feature where you can use QSUM, or cumulative sum tracking of energy use, and this is a prime example of that. So you can see a baseline in the graph here, and of course, as each month goes along, you can see the energy use tracked, and as the graph moves in a downward direction, you know that you have energy savings. Where it levels off, and you can see where the graph has leveled off in certain months, or where it even comes up a little bit, then all of a sudden you know that the energy savings is kind of stopped or come to a halt. It's leveled off and the trend is reversing for some reason. So again, it's a good tool to take back and have those conversations with staff and contractors, and, you know, see what made that momentum switch happen in terms of energy savings, and what could be done or what has been done to correct it. Next slide. So I just wanted to note or remind people that RETScreen is a great benchmarking tool. You can put your building into RETScreen and it'll automatically benchmark your building against others around the world, and in a weather-corrected fashion. Next slide. There's also a great degree of interoperability. When I talk to the folks at Service New Brunswick, they love the fact that they could take information or data they had loaded into Portfolio Manager and automatically migrate that into RETScreen. So there's all kinds of ways. If you're tracking energy use in an Excel file, you can also migrate that into RETScreen, and it's all done in a matter of seconds. You don't have to repeatedly take data from here and put it there. Next slide. And of course, performance analysis is a great tool for tracking building and performance as far as facilities go. And as it shown on the graphs, there's all kinds of different graphing that you can use through RETScreen. There's cumulative sum or QSUM as well. And you can balance point the impact on based on degree days. And there's many, many dashboard and reporting options in RETScreen. Next slide. So just a reminder, I just want to leave folks with a reminder of what Healthcare Energy Leaders Canada does, and you'll get a copy of this presentation, so you'll have all this at your fingertips. And next slide. Some contact information. If you have any questions at all, feel free to get a hold of me, and we'll do what we can to find the answers for you. And I'm going to turn it over. That marks the end of the utilization of RETScreen samples. And we'll turn it over to Stephen Dixon, and Stephen's going to do a demonstration on the use of RETScreen for renewable project applications.
Great. So Dan, I thought I saw a question there. So if you want to queue up some questions maybe for a little bit later, that would be great.
Yeah, sure.
So before I jump into renewables, I just want to revisit something that if some of you have seen some of my workshops over the years, and some of them maybe haven't, this will be a new piece. But basically, I often get asked the question, where do renewables fit? And I always like to say, as the third option in a sequence of options that you can exercise to cost effectively reduce energy consumption, reduce greenhouse gas emissions. And the first step is always to minimize usage, or I like to say eliminate waste, energy we don't need to use. It doesn't affect anything in terms of service delivery. It's just energy that's not needed. So that's always the first priority. And some people will call that low-hanging fruit. Some people say low cost, no cost, but it's not no-brainer. And that's where the behavioral side of energy management comes in, is really eliminating waste. But it is the first priority, and it will deliver quite nice savings at a relatively low price. Then we move into improving efficiency. And RETScreen has tools for all of these things. I mean, JJ, you were talking about using the motion sensors to control occupant or to sense occupancy, the vacancy sensors to sense vacancy, and then to control the lights and the HVAC systems appropriately. Well, that really comes down to minimizing usage or getting rid of waste, energy you don't need to use. RETScreen also has tools then for improving efficiency, looking at the efficiency of lighting systems, fans, pumps, all those types of things. And I always like to say that there's really two forms of efficiency improvement. There's operational efficiency improvement, which includes things like filters, and then there's the technological efficiency improvement. Those are things like changing devices to have a more efficient boiler, a more efficient lighting system, and so on. But essentially, the point I want to make here is that it's only once we've exercised those two options, I think, should we really be looking at the supply side option, which include things like heat recovery and renewables. I always like to say it doesn't make sense to leave the lights on in your basement, even though they're LED, because waste is waste no matter how efficiently the light bulb converts electricity to light. And likewise, it doesn't make sense to put a solar PV panel up there, which seems to be popular today, to overcome inefficient use or wasteful use either. So even though we've got an LED light bulb, maybe we're not controlling it properly. Do we really want to build our PV systems to that load? So the key message here is to minimize the requirement first through minimizing usage, getting rid of waste, improving efficiency operationally and technologically, and then to consider all the options on the supply side, which comes down to things like heat recovery and what we're going to focus on today, which is renewables. So I've looked at 4 renewable options. I'll be looking at 4 renewable options today. One will be PV, one will be solar air heating, one would be geothermal or ground source heat pumps, and one will be solar domestic hot water. What I've done is I've looked out there and found a couple of examples of where this has been applied and tried to build a healthcare-like example around it. Some of them are easier, some of them more difficult to find, but I've built some examples of how to use RETScreen to analyze these situations. I'm not going to go through because we just don't have the time to build them up from scratch, so I pre-built my examples, but I'll introduce each of the systems with a couple of slides sort of set the context, and then I'll give you a quick glimpse of what RETScreen does or what are the features in RETScreen that we can use to analyze those systems. Just attempt to go in there. And as you'll see in many cases, there's not a lot of inputs and there's a lot of databases within RETScreen in terms of panels and different technologies we can use, so we can pull in and get a first pass or even a second pass estimate pretty quickly. And I enjoyed what you said, JJ, about RETScreen was able to confirm other folks' numbers, and I think that's happened a lot of times. RETScreen, although many people see it as the first step, may be better than the back of the envelope calculation. I think it's a lot better than the back of the envelope calculation. In fact, I used it to verify variable speed drive applications as well. So as simple a tool as it is, it's quite powerful in that regard. So next slide there, Dan, please. So our first system we're going to look at is an embedded photovoltaic system. And what I mean by embedded is that this isn't a feed-in tariff system where we've got a photovoltaic system with a meter which allows us to feed this out. Basically, this is embedded in a facility. It could be net metered or not. There's no storage. And in the situation I'm going to model, it assumes that the load of the building overwhelms what the PV system is able to generate, meaning that we're not generating anywhere near as much as the building consumes. Now, you can build systems with different philosophies, but that's the one I approached here. It makes a nice, simple demonstration. So this isn't a standalone system out in the field somewhere. This is, as pictured here, this comes from a hospital out west, one where I think there's actually the next slide tells us the details of this system. Dan? So on this particular hospital, they use 407 305 watt modules. There was a 100 kilowatt inverter. The cost of the system was about $2.50 a peak watt. And in BC, it turns out that this system would avoid 9.5 tons of CO2. But in Alberta, right, if you happen to be there where the fossil fuel presence in the generation mix is a lot higher, it's 130 tons of CO2 avoided. So you could take one of these examples and just transplant it into your province, just like you did earlier, JD. You talked about with the virtual energy analyzer. You can simply move a project that works in one province to a different one and actually see how it works a lot better when it comes to reducing GHGs. And overall, then, this project has an internal rate of return of 9.6%. In other words, like putting money in the bank at about 10% interest, which I think is a pretty good return. So, Dan, if you want to turn over control to me there, I'll bring the system up and just give folks a look. There we go. All right, you can confirm, Dan, that you can see that?
Yeah,
so,
all good.
So RETScreen is kind of neat. It does a number of things. The thing I really like about it is you can put a picture in when you're doing an analysis, and I always encourage people to document their stuff by putting pictures in. At the bottom of every page, you could actually build a description of this project as you were developing it. So some really cool features like that just makes it a lot more usable. So we're able to select the location. This facility, I modeled it after the one in the case study of the hospital in Port Alberni, and which was detailed on the reference on that previous slide. So we jump into the energy analysis tab of RETScreen, and all of the systems we're going to simulate here today are done within the energy analysis tab with the exception of one, and that's the geothermal or ground source heat pump, because we use the combined power heating cooling module to do that, which is kind of separate. So within RETScreen, we probably looked at this in previous webinars, but you have the ability to simulate the energy use in many, many different kinds of systems. So these are the end user systems, but you also have under step 4 on the ribbon bar at the top here, the ability to add solar air, solar hot water, which I'm going to do as well, and also a photovoltaic green power wind turbine. So I've used the photovoltaic system today. Now, in order to do this, I first need to have a usage of energy in the building. So what I've done is, I know that this building has a 250 kilowatt demand, and I know that it consumes about 1.5 million kilowatt hours of electricity a year. So I simply go into the electrical equipment module. It's a little trick here, and I put in 250 kilowatts as the demand, and the load factor, which I set as the duty cycle here, the load factor is the relationship between your consumption and your demand. And then I use on operating hours of 730, which we're saying is we're peak demand at about 70% of the time. And ultimately, that gives me my 1.5 million kilowatt hours. So that gives me my base and a proposed case, which are identical. Now, if I chose to, let's say, maybe I wanted to reduce do some work here to improve the efficiency, get rid of waste. So maybe I could knock this down to 220 kilowatt hours. So my base case is now different from my proposed case. In this case, I'm not going to model that, but I would encourage you to think about that. As I said, waste, efficiency, and then supply. So if you're doing the photovoltaics, make sure you exercise all that you can in terms of reducing consumption first. And you can do a first pass at it here. Maybe I can knock 30 kilowatts off my demand. Maybe I can drop my load factor somewhat. But right now, I'm just going to leave my base and my proposed case the same. That's a neat little trick up there on the ribbon bar, copy, paste, to propose. Make sure you're beginning and ending at the same point. So now I can jump over to my photovoltaic system. So in this case, I have a couple of options. I can use a level 1 analysis, which is very simple. I put in the kilowatts of my system. I put in what's called the capacity factor. Now, I don't happen to know off the top of my head. I know for here what it would be. It would be around 12%. But for that location there, I'm not sure what the availability is at full power of the system. So I use a level 2 analysis, and I move through this, and I enter in the type of array that I have. It's a fixed array. I've got it at 30-degree slope facing due south. It's a single crystal. I can go into the product database here and, in fact, pull up a particular module, and this is the one that was specified in the case study, so I was able to find it and actually drop it right in here. So I'm simulating the exact module that was used in that particular hospital. It brings up information around the efficiency of the modules, and I specify the number of units being 407. I specify a little bit of information about the the losses in the system, the size of the inverter, and so on. And eventually, it comes and tells me that the availability or capacity factor is 14.4%, and that will, in fact, generate 156,516 kilowatt hours a year. Now, I've got a cost in here of $320,000, which is based upon the 407 modules, the 124 kilowatts, and the $2.58 a peak watt. Now, actually, the case study specified 320, so I kind of back calculated that for the slide a bit earlier. Now, so that's great. So we've got the amount we can save. We can look at the savings right here, $23,000 worth of savings. But what's more important then is we can also look at the emissions. So here are the emission reductions in BC. But as I said before, RETScreen is really handy at doing this. Let's say the hospital was in BC. I'm looking at a sort of a standard project, so maybe I want to move it to Alberta. So now it tells me I have 130 tons of emission reductions, equivalent to about 24 cars taken off the road. So RETScreen is very flexible at doing this kind of what-if analysis. And we can move on over to the financial analysis, where we can calculate the internal rate of return of 9.6%. We get a nice cash flow chart. It is adjusted for inflation. We can see that even though none of us like inflation, inflation makes energy projects a lot better. And we can go even further if we want to and do actually a full-blown analysis where we take into account the time value of money, discount rate, and so on. And we can calculate not only the internal rate of return, but what's known as the modified internal rate of return. And in fact, also the, the annual life cycle savings or the net present value. So bottom line here is we've got a very, very powerful tool for even doing full-blown financial analysis, if that's something you choose to do. This project actually happens to maybe not look as attractive as it could. Now, I've got a discount rate here of 8%, but you probably, within the healthcare sector, would be using a 3% discount rate, which is more reasonable. Maybe costs are inflating by 4%. At this point, this project now has a 2-to-1 benefit to cost ratio. Very, very attractive project, right, for an institution. It's got a net present value of $347,000, which says this is the project we want to consider. So we went from an idea. In fact, all I did, and Dan, you can go back to the slides there. Go back to the slide that we left off on. All I did was to take the data from a case study here and actually create this particular RETScreen analysis. So that's the information you see there is really all I had was the location, the number of modules, the size of the inverter, the cost per peak watt. Everything else was calculated by RETScreen. Took about 10 minutes. So, and there's lots of great videos online on how to do this. Go to the RETScreen YouTube channel, and you could walk through any one of these types of projects pretty quickly. So Dan, if we go to the next slide, we'll have a look at the second system I'm going to look at. This is the solar air heater for ventilation. It's actually quite popular in the industrial setting, but it's actually quite useful in any facility which has a higher requirement for heating of outside air for ventilation purposes. And there's actually a hospital in Flin Flon, Manitoba, which utilizes this. I believe in this hospital, if you look at the picture on the bottom right-hand side there, the yellow side was before, the black side is after. So the hospital probably was in need of a bit of a upgrade on the outside. I've seen this in a senior's home down in Windsor where they had a brick spalling problem and they needed to add cladding on the outside. So the engineer or one of the facility folks there actually came up with a great idea of using a solar wall, because in that particular building they need a pressurization air, outside air coming in on a regular basis, and the solar wall was a way to offset the cost of heating that. So in RETScreen, we can model this pretty easily. Dan, if you want to go to the next slide. And so what I've done here in RETScreen, again, I didn't have as much data on this particular hospital, but I simulated a system where we're bringing 6,000 CFM of outside air, and we have a requirement internally of 22 degrees C air 24/7. That required a 3,800 square foot solar wall, which actually did come from the case study. And in the case of Flin Flon, I believe it was running on number 2 oil, diesel oil and boilers, so 59 tons of CO2 was the result. But in fact, if you were doing this in a hospital heated by natural gas, you'd probably have a lower CO2 reduction, obviously, because there's less carbon in natural gas. And this one had a really interesting IRR, internal rate of return, or effective interest rate of 17.5%. Dan, if you'd like to switch over for me, and I'll just give people a quick view of how we do this in RETScreen. I guess I have to accept that at some point. There we go. Thank you, Dan. All right. So again, I've got my picture in here, which I grabbed from the case study that we were simulating here. Here my location is Flin Flon, Manitoba, so I'm using the actual information from Flin Flon in terms of the solar radiation that's there and the outside temperatures and so on. So these aren't just, you know, a rough, crude approximation. It's a pretty nice little simulation we're using here. This is daily solar radiation on a horizontal surface, but well, wait a second, aren't we on a vertical surface? RETScreen has the capability of, no matter what you're doing, when we go into our energy analysis and we go into our solar air heater, right, we in fact can tell it what the slope with respect to the horizontal is and what the azimuth, that is the angle with respect to south, is, and whether it's fixed or tracking. So RETScreen then adjusts that solar radiation resource for the particular situation that we're in quite adeptly. Now, when we go through this one, we have to provide a little bit of information about the indoor temperature, also the R value of the wall. And you say to yourself, well, why do I need to know about the R value of the wall in this case? Well, it turns out that, and this was shown on the slide, and you can have a look at this later, but the solar wall does two things. It's what's called a transpire plate. So it's a wall with basically little holes in it, which won't allow water to penetrate, but will allow air to be drawn through it. The effect of putting that on also is to improve marginally the R value of the wall itself. So in the case of that hospital, I didn't know what their R value was, but I kind of looked at that older building and I put an R6 in there. And so this will marginally improve that relatively low R value as well, in addition to, during sunny times, obviously, heating that air at 6,000 CFM of air coming in. Again, we have a database where we can pull up the characteristics of the solar wall or the solar air heater. I'm using the term solar wall in that case, and that is a brand, or as part of Conservable Engineering's product, but the generic name is a solar air heater. It allows me to select a color. If I wanted to use a different color on this facility, I could, with some marginal effects in terms of the performance. Not as much as you might think, but it allows us to adjust for the color of the wall, because not everybody wants a black wall in their building. The area of the wall, whether there's some solar shading, whether the thing is sheltered from the wind, because if it's not, then obviously its performance is going to be lower. We can also account for the fact that because of the fact that this is an additional delta P or pressure drop drawing the air through this, we have some incremental fan power, so we take that into account as well. We have the cost of the wall, and ultimately then the amount of energy in the base in the proposed case. Now it says boiler here. Right, so what it's asking us is, what heating system are we using traditionally to do this? So in addition to actually entering in the 6,000 CFM that we draw into the building, we also have to enter in the actual heating system that's used to heat the air in the base case. So that's a boiler, in this case, a diesel boiler, or a number 2 oil-fired boiler with a 65% seasonal efficiency, which is not good, but I mean, when you consider all the things that happen in a plant like that, it's probably not unrealistic. So again, we can look at our emission analysis, right? So here we have the 60 tons of CO2 when it's in Manitoba, but if and really it's not so much the province now in terms of electricity that comes into play here, it's the fuel that's being used. So in order to get more or less savings here, I would have to use, in my base case, a boiler which using a different fuel. So if I were to flip this over, I can't do that here because I don't have that set up, but if I were to go back here and I were to specify this, we're using natural gas. There we go. I'll just flip that in here. And I'll go to my boiler, and that will automatically assume the natural gas, and I go to one of my emissions, and now we've seen that we're now down at 39 tons of CO2 because we're running a natural gas boiler as opposed to a number 2 oil-fired boiler. Still a pretty good project from the point of view of the greenhouse gas emission reductions. I'm just going to go back and set my project back to number 2 oil to make sure that my financials come out correct. Number 2 oil per, I believe I had per liter. And if that's not your price per liter, don't worry. You can enter your own price per liter. We go to our financials and we see that this solar wall pays back in about 6 years. I think more attractively, it has an internal rate of return of 17%, which actually I believe is a much better way to state the value to the organization of this type of project. And in fact, what we would find, it would probably have a savings to investment ratio over a 10-year life of probably, or 20-year life close to 2. Actually, it might even be more than that. Let's have a look. Let's go into this, and we're going to set our discount rate to 3%, which is probably more appropriate for a hospital. 25-year project life. We're not going to finance this thing. And in fact, when we look at this, our savings to investment ratio down here, called the benefit to cost ratio, is 3.4, which means over the life of this project, it's going to give you back 0.4 times as much money as you invest into it. For any organization, that's probably a pretty attractive, certainly an institutional organization, attractive investment. So again, RETScreen has gone from a basic idea. I started with very little information, just what I could find in that case study, and all the way through to a financial analysis. I can tailor it to my situation. You know, the virtual energy analyzer allows you to sort of create a predefined building, but using tools like this, we can then become even more incisive once we get into a particular system or piece of equipment. So Dan, if you want to throw us back to the slides there. So the next system we're going to look at is the geothermal, or what's otherwise known as the ground source heat pump. And in this situation, what we're doing, as many of you know, we could do an air source heat pump here as well. The only thing we would really have to change would be the cost and the what's called the COP, or the coefficient of performance. The COP being the number of units of heat that we can pull from the ground, or if it was an air source from the air, for every unit of electricity purchased on average across the heating or cooling season. In this case, will be heating and a cooling season. We'll have a different COP for each. This type of system typically, because it's a lower temperature system, will work better with more efficient buildings, ones with lower loads. The new building is definitely a good example of this. One of the things that when I was sort of looking around for a case study on this one, I discovered this amazing quote coming from the folks in Quebec. There's a reference there about a Quebec City hospital. And what they said here was, it's much cheaper to recover internal heat versus digging in the ground to reach the heat in the soil. So we took as much advantage as possible of the existing energy in the building. And this comes back to what I was talking about before: waste, efficiency, then supply, but before renewables, considering recovery. RETScreen, in many, many cases, there's probably a dozen different ways to look at recovery of energy on your ventilation, your hot water systems, and so on. So again, you can reduce your conventional load through heat recovery before you consider geothermal or other types of renewable sources. So I just wanted to emphasize that fact. Getting the order right is going to allow us to build the most cost-effective solutions, but at the same time, the greenest solutions as well. Dan, the next slide there. I can introduce this example. Now, for this one, I didn't actually have a building that I felt comfortable modeling from a case study. So I created a little 1,500 square meter clinic And I'm going to basically start with a base case of gas heating, electric cooling, and then I move to electric ground source heat pump, where I'm providing the heating cooling from electricity via heat pump or a traditional air conditioner in the summer. And a heat pump is simply that. It can reverse itself and provide cooling in the summer and heating in the winter. In this case, the IRR is about 8.5%, a little lower than the previous one, but still, because we're moving from gas to electricity, in a sense, and electrification, 37 tons of CO2 avoided. So, Dan, if you want to flip me over, and I'm going to make sure I get to the right one here. So I'm not sure where this building is, but I thought that looked like a little 15,000 square foot clinic somewhere in the country. So again, I can specify my location, and this one I think I've placed, that's very close to Algonquin Park. Maybe it's close to a little town called Combermere, Kent. So we can place our pin wherever we want on the map, and we can build then our project. Now in this case, we're going to be using the combined heating and cooling model in RETScreen. It allows us to actually look at cogen systems, combined heat and power systems, ones that provide heating, cooling, and power, but it also allows us to look at converting a building, say, from a traditional electric air conditioning, gas heating, over to a situation where we're using a heat pump for both purposes. So we start off with our system selection, which is this picture here. We specify the cost of our purchased fuels, natural gas and electricity. We can then specify our base case heating load. So in this case, natural gas with a 70% efficiency, and I specify the heating load for the building. This is kind of an end run and doing a lot of the building simulation calculations. 40 watts per square meter heating load. And if we're using RETScreen and you're wondering what that would be, you can simply click in here and you get some really, really cool help, right, in terms of understanding what the design heat load for your building is based on insulation levels and design temperatures. So some very useful assistance there. I specify that because it's a medical building, they have a fairly good hot water base load demand of 25%. And then I also specify my cooling load at 25 watts per square meter and no non-weather dependent requirement for cooling in this case. And finally, RETScreen summarizes for me what the heating and cooling curves are going to look like in the base and the proposed case. Now I can modify my proposed case before I actually go to the heat pump. Let's say I want to exercise some heat recovery. Let's say I want to reduce my traditional consumption. Well, I can simply go in here and I can use end-use measures here. So heat recovery might be able to allow me to reduce consumption by 25%. So I can enter that in and build that into my plan moving forward for that. So, all right, get rid of that message. And finally, now I can move towards specifying what my proposed system is going to look like. So for the cooling, I'm using the heat pump, right? And I specify it's a 15-ton capacity, and it's got a cooling COP of 400 or 4, sorry. And then the heating itself, I'm specifying I've got an equivalent COP of 400%. Now, one could argue that maybe I could push my COP on my cooling up to 5. I just use the same number in both cases, but typically it might be. So somebody says they're only seeing the slide deck and not RETScreen. Did Dan? Can you see if I can take over here?
I'll send you over, yeah.
Yeah. There we go. Okay, so here we go. Sorry about that, folks. What I had gone through there was the system selection, the type of system we're using, the cost of the energies that we're using, the heating load specified in fairly simple terms, watts per square meter, and then a domestic hot water load. The cooling load, simply watts per square meter, and using electricity. And then summary of the load characteristics. So what is my monthly electricity and gas consumption going to look like, which you can calibrate to your existing consumption if you have one. This could be a design calculation. Here's my heating equipment, being in the proposed case being the heat pump, right? Sorry, that's the cooling equipment, that's the heating equipment. And finally, I can look at with the way the system's operating, the energy being delivered from it. But again, more importantly, is that we want to know what did this do for our carbon emissions. So here, what we see here is that this system has basically kicked the pants on the carbon emissions. It's reduced it from 41.4 tons of CO2 to 4. So this is a really good project from the point of view of greening this facility. Maybe it's a new facility. It's now a greener facility. And we can also look at the financial aspects of this one as well. This one has a little bit of a longer payback, but that's what you would expect from this type of system. Moving forward, I'm sure we'll see these things improve in terms of the technologies as they gain market share. And again, I would contemplate, if I was looking at this at the design stage, maybe I want to look at an air source heat pump. So I could go back there and I could adjust my costs, right, for what I put the cost in here, $50,000. So maybe I go with an air source heat pump. Now I'm going to take a hit in terms of my efficiency, my COP, but then again, that may be a trade-off that I can make. But I can test that trade-off really quickly with RETScreen. Okay, Dan. We're closing in on our time here, so I'm going to have you take me back to the slides one more time. So there we go. Okay, so the final system that we're going to look at is a solar domestic hot water system. So this is a system, fairly traditional type of solar system, one that's used for heating hot water. And again, this is kind of like an embedded system, just like the PV one was before. I actually modeled this one on the basis of a case study that I found from out west in Summerland in BC, which is a fairly sunny place, which would make sense. But I've seen these systems work in less sunny places as well. So next example there, or next slide there, Dan. So it's a 112-bed hospital, 36 collector panels. There's a pump for the collector, storage tank, and this one actually avoided 48 tons of CO2. So I'm just going to quickly flip back to the RETScreen on this one, Dan. You can give me control again. Should we do this one right here? There we go. Thank you very much, sir. All right, so again, here we're using what's called an evacuated tube collector. This is actually a fairly efficient, can generate relatively high temperature hot water, but it's not a cheap system. By any means in this picture. Now, we may have simulated this one a little bit differently. Yeah, so I used the glaze collector in this situation. So again, a 45-degree slope, which is appropriate for that location. Some information drawn from the database. All this blue data comes out of the database. So if you can use that database in RETScreen, it's going to save you a lot of time digging up information. I fill a bit more information in. It'll actually suggest to me, in order to meet the load I have here, the load being, well, what was the load? Well, it says 60 degrees C water. Right, well, where did that come from? Well, if I go over here to my hot water model, here I can actually specify a 112-bed hospital. It suggests that that hospital would use 22,000 liters of water a day, and I can specify the temperature. It takes into account the ground temperature, and the incoming water temperature changes from time to time, and ultimately we now can actually construct the base case, which is the 474,000 kilowatt hours of water heating. That's heated by a conventional natural gas boiler or hot water heater with a 70% efficiency. And so the solar water heater, through all its details here, now can displace 40%, what's called the solar fraction of 40%. And we've also factored in here the energy required to operate the pump to run the water up to the solar collector as well. So again, we can have a quick look at the emission reductions. That's made a pretty good dent in our emissions, about 50 tons of CO2 in this case. And from a financial standpoint, a longer payback on this one. But nevertheless, if we were looking at getting those emission reductions, that's like taking many cars, light trucks here, 9 cars and light trucks off the road through one relatively simple solar system. You can have a look at the case study in that one. It's on the slide when those get sent out. Well, that's a very quick tour. 1 minute to go. I'll hang around here, and if you have some questions, Dan, I'm going to flip it back to you.
Perfect. Thanks, Stephen and JJ. And yes, so Stephen's information is listed there. We do have a couple questions here. So I had one earlier. It says, I'm currently doing a grad project and the scope is one of the hospitals. Do you recommend a certain roadmap to follow to model energy consumption baseline at the hospital? And do you have any references?
So you're talking about a statistical baseline, I assume, in that case. So what I would suggest you do is you go to the RETScreen YouTube channel. I believe they're up there now. We've recently posted or created a set of videos. If they're not up there now, they will be up there soon on doing a performance analysis from one end to the other. My email is in the last slide too. I can certainly send you along a procedure for doing that. But basically what I would do is I would build a model that's based upon certainly if you're looking at the gas consumption, heating and cooling degree days, and also the electricity heating, cooling degree days. There may be some relationship to both, test both of them. The other thing I would look at is there probably is a variable, which is the extent of clinical activity in the hospital, depending on if the kind of facility, maybe if it's a clinic, it may be the number of days of clinic activity or something like that. So generally you can model that kind of situation with about 2, maybe 3 variables tops. It's relatively simple. I think the ones that JJ you were showing earlier that came from New Brunswick, they were probably just using 1 or 2 variables in those situations, correct?
I believe so, yeah. So
yeah.
you don't have to make it overly complicated.
No, you don't. That's the one I encourage people. Don't, like a lot of times people will start and try to create 10 different variables in a model, independent variables. And in fact, usually 1, 2, or 3 work really well. And you use the Q-sum technique to figure out whether you need more. If you can't explain the variation, if it's cyclical in nature, then you probably need another variable. But if you can explain the Q-sum, then you probably nailed all the variables you need to deal with. And it's a pretty elegant technique in that way.
Thanks. We do have one more question, I guess, while we're going a little bit over time, if people can stay around for that. So the question is from Mohammed Anani. So it's basically, I'm trying to model one hospital building in the Ottawa region using RETScreen. Since I am still a beginner, I struggled defining boundaries within the building envelope. Some areas within the same building work for 24/7 and others don't. I'm wondering if you could shed some light on this topic.
Yeah, so RETScreen can be pretty flexible. If you want to flip the screen back over to me there, Dan, quickly, I can just show folks what I would do there.
Sure.
Okay, accept. So in RETScreen, what you can do in your facility, I'm going to set this one up here. So in fact, I can go in here. Once I've defined my fuels, I can define my schedules, and I can add schedules for different parts of the facility. And then once I actually get in and I create a building envelope model, let's say, which is the building envelope in a certain area, I can pick from these other schedules and apply those schedules to the building envelope. If I have ventilation systems that are in particular areas, again, I can pick those schedules. So I can mix and match my different types of end uses with my different types of different schedules. And the schedules are flexible that you can specify setback, setup, temperatures for heating and cooling, and then a weekly schedule as well.
Perfect. Thanks. So if anybody has any other questions, you can add them into the chat. Also, I can unmute people.
It's never on point.
Right. So yeah, if anybody had any final questions before we head out, you can put them into the chat, and also I've unmuted everyone.
I just want to ask you something. What's in it for me?
All right. That sounds like it. It might be the end there. Thanks everyone for allowing us to go a little bit over time, and thanks to Stephen and JJ for presenting today with us.
You're welcome. Yeah. My pleasure.
Yeah,
my pleasure as well. Thanks to everyone for joining us today.
Yeah, and I'll be sending out a recording of this along with the 90-day free trial for RETScreen Expert. So you can expect that in your inbox today.
And I'll just add that if you're starting to play with it and you get stuck on anything, my email address is on that last slide. As I always say, the help desk is open. I'm more than happy to take a look at your RETScreen file, answer your questions. Love to do it. I learned something, and hopefully you'll get down the road. Thanks, everybody.
Thanks.